All right, everyone. This is Dr. Baker, and today this video will work with Module 2B problems, and Module 2B for the course MAT0022 deals with multiplying and dividing fractions and mixed numbers. We will start with number 1 and continue with the highlighted problems. With number 1, we're asked to multiply and write our products in simplest form. Now, when you're asked to write your answer in simplest form, what that means is to find out if there's a greatest common factor. Is there a GCF? You're really trying to make sure that the numerator and denominator cannot be divided by the same digit. Ideally, the greatest common factor, so you can put your answer in lowest terms. Now, the traditional way to multiply fractions is just to multiply top times top and bottom times bottom. So numerator times numerator, 5 times 7 gives us 35. Denominator, 9 times 11, you'll get 99. Now, in this case, you can't divide 35 and 99 by the same digit and reduce it other than 1. So we'll leave our answer as 35 over 99. This is the traditional way, but we'll also talk about another way that we can get to our simplified answer quicker. And we'll start with that with number 2. We have a fraction, well actually we have 3 fractions we're multiplying. 5/4, so 5 divided by 4 times 1 divided by 3 times 2 divided by 25. Now, the cross-canceling method is when we look at terms that are diagonal to each other. We're looking at 5 and 25, for example, and you find terms that can be divided by the same digit. 5 and 25 can both be divided by 5. So we want to go ahead and simplify these fractions so we can get to the simplified answer quicker. We'll divide 5 by 5 and get 1. We'll cross out the 5. And 25 divided by 5 gives us 5 in the denominator here. So we'll cross out the 25 and 5. Now we'll look at terms that are diagonal and make sure that there aren't any other that can be divided by the same digit. And if you look closely, you see 2 and 4 can both be divided by 2. So we'll divide 2 by 2 and divide 4 by 2. 4 divided by 2, we'll cross that out because that becomes 2. And 2 divided by 2 becomes 1 in the numerator. Now, our new fractions, after we simplify, the first fraction becomes 1 over 2, becomes 1/2, times our middle fraction, 1 over 3. It stayed the same. We didn't make any changes there. Our third fraction, the numerator became 1. Remember, 2 divided by 2 became 1, and the denominator became 5. Now we'll go ahead and multiply all 3 top numbers. So all 3 numerators, 1 times 1 times 1 becomes 1. And then all 3 denominators, 2 times 3 is 6, times the third denominator, which is 5. So 6 times 5, the denominator becomes 30. And 1 divided by 30 is our answer. All right, let's look at number 5. We're multiplying, and now we have fractions in a different form. So we have 2/7 times 4 and 3/8. Now this mixed number, we want to convert this mixed number to an improper fraction. You recall the rules for converting mixed numbers to improper fractions from Module 2A. 4 times 8, you multiply the whole number times the denominator, and then you add the numerator. So that's why I put the dot there to indicate multiplication, and then you're going to add the numerator to that product. So this becomes 4 times 8 in the numerator plus 3. The denominator stays the same. So 8 remains in the denominator. Now if I simplify that, 4 times 8 gives us 32. And then 32 plus 3 becomes 35. So the numerator will be 35. The denominator stays the same, it's 8. So we'll replace this mixed number with 35 divided by 8. Now the first fraction, 2 over 7, remains the same. So we'll bring down the 2 over 7, and let's check and see if we can cross cancel here. We can. Look, 7 can be divided into 7, and 7 can be divided into 35. So 35 divided by 7, that becomes 5. 7 divided by 5, that becomes 1 in the denominator. And 2 and 8, we can divide 2 and 8 by 2. 8 divided by 2 becomes 4. 2 divided by 2 becomes 1. So what is our new fractions after we cross cancel? 1 divided by 1 for the first fraction, the numerator is 1 and the denominator is 1. For the second fraction, the numerator is 5, so times 5 divided by 4, the denominator is 4. And now we multiply numerator times numerator. 1 times 5 becomes 5. 1 times 4 becomes 4 in the denominator. So 5/4 will be our answer for number 5. And now looking at number 6, we have two mixed numbers this time. So we have to convert both of these mixed numbers to improper fractions. 1 times 5 plus 1 for our numerator. 1 times 5 plus 1 for the numerator of the first fraction. And remember, the denominator stays the same. So 5 remains in the denominator. Times 6 times 3 for the second fraction in the numerator. 6 times 3 plus 2. And remember, the denominator stays the same, so our denominator will remain 3. Now we just want to simplify here. 1 times 5 is 5 plus 1. So that becomes 6 in the numerator divided by 5. Times, here we have 6 times 3, which is 18. And 18 plus 2 becomes 20 in the numerator. Remember, the denominator is 3. We want to simplify here if we can. Look at those diagonal terms. 3 can be divided into 3, and 3 can be divided into 6. So 6 divided by 3, this becomes 2 in the numerator. 3 divided by 3 in the denominator, this becomes 1. And then 5 and 20. We can divide 20 by 5 and 5 by 5. 5 divided by 5 becomes 1. 20 divided by 5 becomes 4. So what is our new fractions after we simplify the first fraction? The numerator is 2. The denominator is 1. Times the numerator of our second fraction. We did 20 divided by 5. That becomes 4 in the numerator. And 3 divided by 3 becomes 1 in the denominator. Now we multiply numerator times numerator. 2 times 4 becomes 8. Divided by 1, and 8 divided by 1 is just 8. This is our answer. All right, let's look at number 9. A sidewalk is built 12 bricks wide by laying each brick side by side. So you got a bunch of bricks that you're laying side by side. How many inches wide is the sidewalk if each brick is 3 and 13/16 inches wide? So we want to know the total length if we have 12 bricks that have a width of 3 and 13/16. So we're going to take the 3 and 13/16, 3 and 13/16, and we're going to multiply it times 12 since we have 12 of those bricks. Now 12 can be made in fraction form or written in fraction form by simply placing it over 1. So draw your fraction bar and put 1 in the denominator. That's how you make any whole number a fraction. Divide by 1. Now we're going to convert our mixed number to an improper fraction before we multiply. All right, so we're multiplying 3 times 16, which gives us 48, plus 13. And 48 plus 13 becomes 61 in the numerator. 61 in the numerator. The denominator stays the same, so the denominator remains 16. Times 12 divided by 1. Now look at our 16 and our 12. We could reduce a little bit there because 12 and 16 can be divided by 4, and that's what we'll do to reduce these values here. 16 divided by 4 gives us 4 in the denominator. 12 divided by 4 gives us 3 in the numerator. So our new fraction that we get after we simplify, we have 61 in the numerator divided by 4 times, remember we divided 12 by 4, that became 3 in the numerator of the second fraction, and the denominator was already 1. So now we just want to simplify more. We'll multiply the numerator times the numerator, so 61 times 3, which gives us 183. Divided by 4 times 1 in the denominator becomes 4. All right, and that's our answer, 183 divided by 4. Now let's look at number 10. So we're moving on to division. The rule for dividing fraction, you can remember this as keep, change, flip. When you multiply or divide by a fraction, all right, you're actually going to change this to a multiplication problem, because when you divide by a fraction, it's the same as multiplying by its reciprocal. So we're going to apply this rule. You'll keep the first fraction the same. In this case, 5/8 will remain the same, 5/8. You'll change the operation from division to multiplication. And then you'll find the reciprocal of the second fraction, which is the same as flipping the fraction. So you'll move the denominator to the numerator and the numerator to the denominator. This will become 16 divided by 3. And then you'll multiply like normal. Check and see if you can cross cancel, and you can here. We can divide 8 and 16 by 8. So 16 divided by 8 in the numerator, that becomes 2. 8 divided by 8 in the denominator, that becomes 1. So what are our fractions after we reduce here? We have 5 divided by 1 times, remember we divided 16 by 8, that became 2 in the numerator, and the denominator was 3. So top times top, 5 times 2 gives us 10, and the denominator, 1 times 3 gives us 3. 10/3 would be your answer for number 10. All right, let's look at number 13. For number 13, we have 3/10 divided by 15. So remember our rules here. We want to keep the first fraction the same, so it'll remain 3/10. We'll change our operation from division to multiplication, and then we'll flip the second fraction. But look, our second fraction isn't written in fraction form. It's a whole number, so we got to make it a fraction. Divide 15 by 1. Then we can flip that fraction. So 15 moves to the denominator, 1 moves to the numerator. That becomes 1/15. We want to check and see if we can cross cancel, which you can here. We can divide 3 by 3. We can divide 15 by 3 to simplify. So 15 divided by 3 in the denominator becomes 5, and 3 divided by 3 becomes 1 in the numerator. So what are we left here after we simplify this fraction? We have 1/10, 1 divided by 10 for the first fraction, times 1 in our numerator here divided by 5. So we want to simplify numerator times numerator. 1 times 1 gives us 1. 10 times 5 gives us 50 in the denominator. 1/50, this is our answer. All right, let's look at number 16. For number 16, a patient is to take 2 2/5 tablespoons, not teaspoons, tablespoons of medicine per day and 5 equally divided doses. How much medicine must be taken in each dose? So we got to divide. We're going to take the 2 2/5, and we want to divide that number by 5. So we'll apply our rules here. We'll keep the first fraction the same, the 2 2/5. We'll change our operation from division to multiplication, and we will flip the second fraction. Now we will adjust the way that these numbers look. This 5, we want to make it in fraction form or place it in fraction form, so we want to divide by 1. That way when we flip the fraction, that becomes 1/5. The 1 goes to the numerator, the 5 moves to the denominator. Now with this mixed number, we want to convert the mixed number to an improper fraction. So 2 times 5, that becomes 10, plus the 2 in the numerator. And remember, the denominator stays the same. So 10 plus 2, that becomes 12 over 5. We'll keep the fraction the same. We just want to change that form. We want to rewrite it so that it's an improper fraction form versus the mixed number. We change our operation from division to multiplication. That dot means multiplication. And then we flip the second fraction. So 5 over 1, we flipped it. It becomes 1 over 5. We'll check and see if we can cross cancel here. And you can't. 1 can be divided into all of these terms, but we can't simplify with other numbers. So we'll multiply across. Numerator times numerator. 12 times 1 in the numerator gives us 12. In the denominator, 5 times 5 in the denominator becomes 25. And this is our answer, 12 over 25. All right, let's look at number 18. So in parentheses, you see 5/7 and 5/7 you see is divided by 7/5 in parentheses. So we have to remember those rules that keep, change, flip. So keep, change, flip. We want to keep our first fraction the same, so it'll remain 5/7. We'll change our operation from division to multiplication, and then we'll flip the second fraction. So the denominator moves to the numerator, 5 moves to the numerator, and 7 moves to the denominator. So let's just multiply now. 5 times 5 becomes 25, and the denominator, 7 times 7, becomes 49. All right, that's the first part of our problem. But remember the second part. Look, the second part, we're multiplying times 5 over 5. Now what is 5 over 5? 5 over 5 is just 1. 5 divided by 5 is 1. So we're multiplying times 1. So 25 divided by 49 times 1. And we know that if we multiply any term by 1, we're just going to get that term. So 25 over 49 times 1 is just 25 over 49. That's our answer. And that completes Module 2B notes. We'll stop here.